We're back. Oh, my lunchbox got in the way. All right. Here we go. Here's the next part. So now they give us a function like this. What do you think they did to get here? Eliminate what? X minus 3. Cool. So that's what they did. So let's talk about your domain first of this. So you could look at it two ways. You could look at it from the picture or from the equation. Technically, what I should have done before I crossed this out is find our domain. Because the domain comes from both of them, okay, before crossing out. So we would say x cannot equal 3 and negative 2. Now I'll cross them out. Now something happens though. So we have the vertical asymptote at negative 2. What do you have at 3? That's called a hole. That's at 3. So notice there's a hole located at x equals 3 from the graph. This comes from the guy we crossed out, the hole. So I'll say the factor, it's called a factor. So the factor crossed out. Factor crossed out. Okay. My handwriting's getting worse. Factor crossed out. How can we distinguish between a vertical asymptote and a hole by looking at the equation for the function? So the main idea is you look at the function so crossing out gives you a hole versus not crossing out on the bottom is your vertical asymptote. So not crossed out is your VA. And remember, they both come from the denominator. Both from denom. So I'm talking about the denominator here. We crossed it out. You have a hole. That came from the denominator. Okay. We can find the y value of that hole. Because it's not, we don't just say it's at 3. We're going to name the actual point where the hole's at. So to do that, if you guys take a look, we crossed out x minus 3, so you were left with this function, x plus 4 over x plus 2. So to find the hole, the exact point, we know the x value is 3. We're going to plug it in to the new equation. That'll get you the y value of that hole. So that's what it's saying. You can find the y value of the hole by substituting the x value of the hole into the simplified version. So in this case, the simplified was x plus 4 over, was it x plus 2? Yeah, cool. So let's plug in 3, because that was our x value. I'll just write it like this. F of 3 means let's plug 3 in for x. 3 plus 4 over 3 plus 2 gets me 7 over 5. And so we say our hole is at 3, 7 over 5. That's the exact point of the hole. No, don't worry about it. I guess technically you yeah, if we're graphing it, yeah, you should know 7 over 5 is a little over 1 point something. 1 point, what was it? 4? Cool. Yes, that makes sense, 1.4. So yeah, a little right above 1, they drew it for your y. Now, we did limits. They were approaching infinity. Now let's talk about when it approaches the whole. Okay. So we're going to be talking about the limit as x approaches the whole, which is 3. And the answer is that y value, 7/5. So keep in mind, when I say approaching, it means it doesn't actually equal. It's just getting closer and closer to 7/5. So that will be how we write this. Let me go down even more. The limit as x approaches 3 of your function is 7/5. Why do I not have the left and the right here? There's only one answer. They both are going to the same number. That's why. Versus when we talked about infinities, one went up, one went down. They were going different directions. Let's see. We'll probably have time to finish this, and then you guys lucked out. I don't think we're going to have homework tonight. Yay. But I did figure that because of how dense this lesson is. All right. So, and tomorrow will be good because that'll give us time to practice in class, and there's a cool activity I want to try with you guys. So, yeah. Question? Wait, Carol, repeat your question. Sorry. I don't understand what you said, like there's one answer. Can you say the difference? Sure, yeah. So, when we talked about vertical asymptotes, right? So if I were to write the limit of the vertical asymptote, the limit as x approaches -2 from the left of your function, you take a look from the left side, it's going to negative infinity, versus the right side, it's going to positive infinity, because from the right, it's going up, okay? So those are two different answers. Now, when we talk about the whole, if we're talking to the left of the whole, it's going to 7/5. From the right of the whole, it's going 7/5. So they're both going to an exact point. Correct. And so the way we phrase it and the wording, use limit notation to describe the function's behavior as it approaches the whole. And if you see, I wrote x approaching 3 because that was the x value of the whole. And it equals on both directions 7/5. Yeah. In fact, let's see. I mean, we only have 8 minutes left. Why don't you guys, we'll finish class. Why don't you guys try this? There's a little more to it. There are 2 holes. Why do you think there are 2 holes? How many things are you crossing out? 2. You're crossing out x minus 3's, x plus 2. So we have x plus 4 over x minus 1. That would be the simplified version. But remember, your domain comes from the whole bottom before crossing out. So, yeah, we'll spend about the last 5 minutes working on that, and we'll talk about it today or tomorrow. But yeah, it'll give me a chance.